First thing you want to do on problems of this type is to get everything on the same side of the inequality. We want to typically move everything to the left side. So what I'm going to do is subtract 9x squared and subtract 20x so that the right hand side of this is left with nothing on it. Now if I do that to the right side of the inequality, I also have to do it to the left side. One thing you have to be careful about is combining like terms. In this particular case, I don't have any like terms to combine because I have an x to the third and a constant, and then I'm subtracting an x squared and an x. So there are no like terms. So when I write this out, then I'm just going to write it as one big polynomial now in descending powers order. Now I want to, if I could, I would try factoring this by grouping, but I can already tell that's not going to work because there's no factor of 9 in the 75, and there's no way I can get rid of the 9. So my other option then is to graph it and kind of see where the zeros are. So I'm going to graph this. In my calculator, I'm going to go to y equals and type in the polynomial part of this, 2x to the third minus 9x squared minus 20x plus 75. And I'm going to graph it and kind of hopefully see some places where it'll cross. It looks like it crosses here at -3. That one looks like a fraction, and then here at 5. So what I want to do then to check that is to come over here and synthetically divide my polynomial. I'm going to start off with the lowest one, the -3. I'm going to synthetically divide this whole thing by -3. So I have 2, -9, -20, and 75 as my coefficients. I bring down the 2. -3 times 2 is -6. Add straight down, that's -15. -3 times -15 is +45. Add straight down, that gives me 25. -3 times 25 is -75. And I do get 0 at the end. So that means that one of my zeros is -3, which means that one of my factors is x minus 3. So now I'm going to synthetically divide again by the next one that I know, which looks to be 5. 1, 2, 3, 4, 5. So I'm going to synthetically divide by 5 just on the remaining coefficients here, not back to the beginning. I bring down the 2. 5 times 2 is 10. -15 plus 10 is -5. 5 times -5 is -25. And again, those cancel. So 5 is a 0, which means that x minus 5 is a factor. Now one thing I should note, I made a mistake. -3 is a 0, so that means that x plus 3 is a factor. And then 5 is a 0, so x minus 5 is a factor. So I need one more factor, but I actually already have it. I have it right here. By synthetically dividing out, continuing down, I'm left with my last factor. My last factor, if I just throw an x here on the first term, will be 2x minus 5. And that's why this fractional 0 happens, this one in the middle, because if I set this equal to 0 and solve, I get x equals 5/2, which is a fraction that is 2.5. And we can see I'm crossing between 2 and 3, that's the 2.5. Now for the purposes of my labs plus, we're going to stick with the improper fraction form of that and say the other 0 is at 5/2, and there's my factor. So now I'm going to use these zeros to create intervals. I always start at -infinity, go to the next number, the smallest number on my list, which would be -3, or the first place where it crosses here. From left to right. The first place it crosses is -3. Now I'm going to use a bracket on the negative 3 because my original inequality symbol had an or equal to on the bottom. So I need to use brackets to include the endpoints. So now I pick up at negative 3 and then go to the next 0 from left to right, which would be the 2.5 or the 5 halves. Then I pick up at the 5 halves, go to the next one, which is the 5, and then from there I have 5 to infinity. Next step is to pick just a number that fits within each interval so I can test it up here. So I'm going to pick negative 4 because that's smaller than negative 3. Here I'm going to pick 0 since I'm going from negative to positive. I know 0 falls between those two. Between 2.5 and 5 I could pick 3 or 4. I'm going to pick 4. And then from 5 to infinity I'm going to pick 6. Now what I want to do with each of these is test them in this inequality here to see if the answer I get when I plug them in is less than 0. If it is less than 0, then I know that inequality or that interval is part of my answer. If not, I can leave that interval out. So if I plug negative 4 in to the polynomial, and you can do this by hand or use the calculator. 2 times negative 4 to the third minus 9 times negative 4 squared minus 20 times negative 4 plus 75 is 20,000. Let's see if the graph agrees with me there. It does not. So what did I do wrong? Oh, I see what I did wrong. Do you see what I did wrong? I missed the parenthesis and put a 9 there. Let's try that again. Oops. Enter. There we go. Okay, I plugged negative 4 in and got, and notice it's 2 times negative 4 to the third minus 9 times negative 4 squared minus 20 times negative 4 plus 75 is negative 117. Now, is negative 117 less than or equal to 0 like I want it to be here? Yes, any negative number smaller than 0. So this interval is part of my answer. And the graph confirms this because it starts out below the x-axis here. So I know that the first part should be less than 0 or on the negative side of the x-axis. The next part is above, so it shouldn't work. So we're going to plug in 0 and see if it will. 2 times 0 to the third minus 9 times 0 squared minus 20 times 0 plus 75. Well, that's 0, that's 0, that's 0, so the answer is 75, which is not less than or equal to 0. So this interval didn't work, just like the graph told us it wouldn't. The next part of the graph is below the x-axis, so I'm betting when I plug 4 in, it will work. So I come down here again, or I think this time I'll just type it all in the calculator rather than write it out. So I have 2 times 4 to the third minus 9 times 4 squared minus 20 times 4 plus 75. This time I get negative 21, which is less than or equal to 0. So this interval works. And again, the graph showed us that. We can always go back to the graph and check. Right there, my lower part. And then from 5 onward, I'm above, so this one shouldn't work. So we chose 6 in that interval, so I want to see what f of 6 is. So I'm going to come back to the main screen, hit second enter to pull up what I did before, and just go back in and type 6 where I had 4s before. 63 which is not less than or equal to 0, so this one didn't work. So my answer then is the two intervals that did work, which would be negative infinity to negative 3 union 5/2 to 5. We always put that union symbol between when we have two or more intervals that work. I know that was kind of a long problem. There's a lot of checking here. First you had to factor, but we couldn't factor this straight up, so we had to graph it first and get the zeros from the graph and then synthetically divide to get the last 0. Once we had the zeros, we could make the intervals, then we pick a number in each interval, test each number that we picked to see if that interval matches our inequality, which in this case was less than. And we always go back to where we had the 0 in there in order to test. If you have any more questions, just let me know.